Welcome to the session. Greeting of the day. In today's class, we are going to see about the solid state welding process of friction welding process. Here, in previous classes, we have already seen about this gas welding methods of various techniques of oxidation weldings and arc welding process of SMAW, SAW, GTW, MIG welding, TIG welding we have seen. And in the later cases also we have seen about the resistance welding processes. The various methods of spot welding, seam welding, friction welding we have already done. In today's class we are going to see about this solid state welding. On that we are going to see about the friction welding process. The remaining part of the welding process is to be studied. So what is the need of this solid state welding process? The name says it is solid state. It means the welding is not done, the material is not reaching the melting point of the object. In case of steel, the melting point of the material is 1500. It won't reach up to 1500 for making the molten material. It will be in the semi-solid state, or otherwise it will be in the plastic stage. Therefore, we are calling this as a solid state welding. Then how we are doing the joining of the dissimilar materials and alloys, it is possible to do. The need of solid state joining, we can able to do the dissimilar materials. For example, we can able to take with the steel and the aluminum material can possible to weld. The joining of the different weld metals like aluminum and superalloys. That is what I told you. Two components of dissimilar materials can be welded, and which gives the solid state welding process, which gives a strong and intermetallic free welds also possible. So the understanding about the microstructural and surface conditions of the workpieces. You see, in the microscopic scale, when we are seeing the workpieces, when we are seeing the specimen, the covered with the contaminant films and oxide layers are there on the base material. This region is the base material specimens. Over there on the surfaces we have some mechanical chemically affected metals. It means a layer is formed by the oxidation treatments, the contaminations, corrosions will be there, and then over there see oxidation layers and contaminated layers are there. This is to be removed, or otherwise this oxidation layer will also one of the part of the welding process. Therefore, how it can be removed? Doing some rubbing actions. These oxidation layers, contaminations can be removed from the fairing surfaces. So, covered with the contaminated films and oxide layers, surfaces are irregular. Surfaces are irregular. So, we have taken two specimens. We are going to weld two jobs here. In this job, we have irregular specimens are there. Where is the contact will be there? The contact will be here. So, the remaining parts are not in contact. We need more force to be applied at this part to make this contact and the friction and rubbing action and the heat generation and the plastic state and pressing. So therefore welding may occur. So these difficulties are there. So we have to take care to make the smooth surface, a flat surface, and non-contaminated oxide layers to be removed. So such taking care to be done during this welding. So how to remove this? How to remove this? Intimate contact mechanically. So when we are doing the contact and friction happens, automatically oxidations comes out. So contaminated films can be broken by a mechanical action. So that is what the friction we are doing to remove those things. Break down the metal oxides by dissolutions into the matrices. The process we are doing. So in this mechanical energy welding, I am calling, we have seen about the gas welding, we have seen about arc welding process, we have seen about resistance welding. Next we are coming to the fourth category of mechanical energy welding process. In this mechanical energy, the various types of mechanical energy is converted to heat. What are they? Mechanical welding, heat is generated by a mechanical energy for softening the fairing surfaces. Which one is the fairing surface? In case I want to weld two zones material, this part is called as fairing surface. So this zone is called as fairing surface. So So there we are going to weld. So that is called a spraying surface of the base metal along with the application of pressure. So I am applying a mechanical energy and applying it along with the pressure to make the plastic state to develop the metallic bonding. So then application of pressure and the mechanical energy combined we are going to do the joining process. So what is this mechanical energy? So this mechanical energy are maybe a friction, maybe a forging, maybe explosive, maybe a diffusion, maybe a ultrasonic. So each one is categorized as a welding process. Friction welding, friction stir welding, forge welding, explosive, diffusion, ultrasonic. So here all the mechanical energy is adapted for welding technique along with the pressure. So that is what now we are going to see about this friction welding method. In friction welding, I am calling this as a solid state joining process, mechanical energy process, and also I am calling this as a solid state joining as because we are not reaching the melting point of the material. We are doing the welding process before that at red hot condition we are doing. So solid state welding process that produces weld under friction and the compressive pressure. So friction is mechanical energy along with the application of pressure. The heat required to produce a joint is generated by friction heating. How this friction is heated? To object to become in contact and we have to rotate, by which a rubbing action, and therefore there at the point of faying surface heat will be generated. At the interfaces of the faying surfaces. The components to be joined are first prepared to have a smooth, even cut surfaces. It means flat, not the edge preparation, some irregularities not to be there, contaminations not to be there, oxidized layer not to be there. Those things are we have removed. We need smooth, even cut surfaces, not contaminated, non-oxidized layers we need. So these things we have prepared first. The specimen is ready, the flat specimen of two specimens which we are going to weld. So these specimens are ready. Now here we have to rotate and we have to apply the pressure and we can able to weld there. That we will see one by one. Friction welding process can be considered as a green process. Why? It is because since it does not generate gases, flames, as like in the SMIW or MIG welding process. There we have generated used fluxes. Those fluxes are used which generates the fumes, gases, flames which are harmful to the welder. That is not happened here. We are not using gas. Gases are not used. Flames are not there. Smokes are not there. Smoke or will not be there. Therefore I am telling it is a green process. It is an environmental friendly. If the smoke is not coming, gaseous shielding gases or flames are not there, then we can tell it is a environmental friendly process. And it is a the process reduces operator fatigue. Why? Because it is automatic. We consider as a lathe setup. We have two objects. We are fixing, and one it is rotating, one it is coming nearer, and we are going to weld. The machine itself will do the job. Only thing we have to set the RPM of rotation, how much pressure we have to apply. Those things we have to set in the machine setup. So that is the less work to the welder. The welder become the operator. Welder become the operator. So the process reduces the operator's fatigue to a great extent. The process is easily automated. Therefore, why it is easily automated? So we consider this as a green process. The working you should see, I am dividing into 4 steps here. I am dividing as a step 1. I have taken 2 specimens of cut, smooth, oxidation free, contamination free specimens I have taken. And then I am assembling those things in the machine setups. I have assembled, and then the machine has to be rotating. rotating to be done. Then the friction will be generated there, and automatically when the application of pressure is there, automatically the heat generated due to heat as a friction, the flash will form and the shortening welding will perform. So that is what I have mentioned here in the pictorial format. Step 1, the setup has been taken and one is rotated. This one member is fixed and it is rotated. We can see here. And then step 2, what I am doing here, step 2, the another member I am taking it in contact with this rotating object. Okay, taking in contact with this rotating object. You see here in this image, in this video, a specimen is kept in the automated friction welding setup 2, and one is going to start rotated. One is going to start rotated, and we are assembling near to make the friction contact. One is rotated, one is pressurized, one is movable, one is rotatable, one is non-rotatable. See, one is rotated and one more side is non-rotated. Therefore, it causes the pressure. So one is rotated and we are coming into the contact. Now the step 3, what I am doing, in step 3, I am applying the pressure. I am naming this as a friction pressure slash for a duration of friction time. Friction occurred. Now the plastic stage has been achieved. Now we are applying the step 3. Upsetting we are doing. Upset pressure, and then I am applying the upsetting time for upsetting time. The total entire welding process will be completed in 5 to 7 seconds. First 3 seconds for friction, heat generated, semi-solid plasticized state will come. Another 2 seconds or 3 seconds for crushing access, and then for the flashes comes out and the welding completed, it is going to solidify. And then step 4, last step. Step 4, here by the application of pressure, the upsetting pressure, the shortening happens. Shortening of specimen and welding completed. Welding completed by solidification process, and we will get the flashes outside. This we call it as flash. This one we are calling it as a flash component. So the shortening occurs in case of 100 mm we are taking, this side will become 98. So the total, this is 50 and this is 50 we have taken. Finally, this side after shortening it will become 48 and this side will become 48. But the joining has been done. That is our need. So then what is the application here? The circular job we can do. Pipe material. There is no 1G, there is no overhead, there is no 2G, there is no 6G. Easily 2 jobs are kept, rotated, connected, welding completed. So the stages, you see, at beginning we have seen the video. Beginning of the flash by heating pressure. This is what I told the parameters. Heating pressure for heating time. So simple contact has been generated, heat, it started to make the material plastic. And second, the flash is developing. This I am calling this as flash. This is I am calling it as a flash. Flash is developed by application of pressure and for the duration of upsetting time. Upsetting pressure, upsetting time. 4 parameters only are there with respect to RPM. So finally, this will be the final after pressure final welded product. So simple, very simple process. See, this is how the final product will look. So this is the flash. Flash one side 2 mm, another side maybe 2 mm. So simple images for our understanding we have taken. So this is about nearly 12 to 16 mm diameter. 12 to 16 mm diameter rod bar we can able to weld. Now we know what are the stages or steps available. Step 1, step 2, we know this. Just working, we will go ahead. One piece is held stationary while the other is mounted in the motor, driven chuck, call it, and rotated against the high speed of 1000 RPM. We have rotated. It is keep on at high speed, it is rotating. We know this, we have seen. A low contact friction pressure is applied for the duration of what time? We are naming this as a friction time. Friction pressure, friction time. To permit cleaning the surface for burnishing actions. And second one, step 3. Step 3, what happens? The offset pressure is for duration of offset time. Here heat, friction pressure, friction time. Offsetting pressure, offsetting time. So here 1 for 1A, stage 1. And the next stage 2 and 2A. Likewise we can just for identification. Contacting friction quickly generates enough heat to rise the opting surfaces to the welding temperature. Therefore, as soon as this temperature is reached, rotation is stopped, because keep on rotating and keep on pressurizing no useful. We are rotating the workpieces for creating the rubbing action, creating the heat only. For welding it is to be stationary. Therefore, we are stopping immediately this 1000 RPM, we are stopping the rotation and applying the pressure. Stopping the rotation, and the pressure is maintained and increased to complete the welding process. So softening is squeezed out from the flash as desired, it can be removed. So you see, in simple, in this sketch we can able to understand what the general idea, what are the parameters we have used. As I told you, heating pressure, heating time, offsetting pressure, offsetting time. This is a stage 1. I am telling this is the stage 2 for understanding. That is step 1, step 2, step 3, step 4 we have did. In stage 1 only heating. For the friction, plastic stage occurred. In stage 2, this plastic stage is pressed to make the joining and shortening will occur. Fractures will come out. So altogether a constant rotation speed at 1000 RPM we have made. Right. Now what are the parameters? Again I am plotting the same working as in terms of graph. What I am doing here, as I told you, heating pressure and heating time. How much I am applying heating pressure? See, at the y-axis the green color, this green, heating pressure is applied for a duration of heating time. Heating pressure is applied for a duration, here the heating pressure, for the duration of heating time. Or friction is generated on the specimen. Early to the rotation is started. See, rotation is given here. Rotation is given up to this 3 are at a time. Heating pressure, heating time and rotation speed. Or 3 are up to this only. First stage over. Heat is generated. Material at the molten state. Now we want to go for the welding process. Now from the heating pressure I am changing to the offsetting pressure. See, this heating pressure, see, it is increasing further. Pressure is increasing further in this direction. See, here it is increased. How long? For the time of offsetting time. Offsetting pressure for the time of offsetting time. Again from here, this time, here it is offsetting time. Stage 1, heating pressure, heating time. Stage 2, offsetting pressure, offsetting time. Welding over. For a constant of rotation speed, during the second stage 2, the rotation speed is dropped down. And then the welding has been completed. So this is same diagram I have replaced here. Assembling, pressure applying, one is rotating, and friction pressure, friction time, offsetting pressure, offsetting time, and joining, flash formation, welding completed. So what we are doing? No flux, no filler, no shielding. Environmental friendly. There are some variations are there. Not only rotation is the welding process. It can be vibrations, it can be shakings, such not only the circular object can be made, but also the square objects. Likewise, we can also make the welding methods. That is what the idea. See how they have did here. We have taken the square joints, kept, and vibration, ultrasonic vibrations they have did. Due to the vibration also, see, due to the vibration also, we can able to generate heat. That heat also is possible, and then we are applying the pressure. Heating time, heating pressure. Upsetting time, upsetting pressure. We can able to do the welding methods. Same video, we have how they are doing the friction welding methods. Very simple only, but only is applicable for rod type or the square joints, not a plate. Plate is not possible. The thin long plate not possible to weld. Somehow it is to be some thickness to be like a square or round bar to be there for welding. Now we came to the applications, advantages. What are the advantages? As I told you, no filler, no flux, no shielding, as therefore environmental friendly, and also no smoke, fumes, gases. Right. Narrow heat affected zone. What is this? Heat affected zone. The heat generated in the welding friction itself, it is very less. We have not reached the melting point. We are done doing the welding process itself below in the solid state joining. That heat is not even sufficient to make melting of the workpieces. Then how it will distribute inside the jobs? It won't. Therefore, the fairing surface only heated, it become molten. And then at the time itself we are giving the pressure to make the weld joint. Therefore, heat affected zones, if the near zones, heat affected zones are very less or very narrow. In the solid state joining process, there is no heat affected zone or very less. Therefore, there is advantage. Heat affected zones may be brittle. Heat, if you are moving towards the other jobs, if your heat is increased, obviously cooling also will be fast. Therefore, it forms a martensite, brittle nature will form. That and all we can able to avoid in the solid state joining process. So dissimilar materials can be welded, like steel and aluminum can be combinedly welded. Light materials are like aluminum, copper are weldable. So faster welding process. What is this faster? Automatic. Just we are keeping within 10 seconds. Friction time takes the 5 seconds. Upsetting time take the 5 seconds. Friction time, friction pressure. Upsetting time, upsetting pressure. Welding is completed. Within 10 seconds, one job is ready. Then we can go for the mass production. 100 jobs in an hour. But in case of manual welding, electrode changing, keeping, welding, rest, fumes, smoke, cleaning, grinding. So such many processes are there, difficulties are there. So in this, nothing else. It is quick. Mass production can apply. Easily automated. Therefore, it is easily automated. What are they? The existing milling machine or lathe can be converted into the friction welding machine. How? In the lathe setup we have a headstock and tailstocks. At one side we can able to fix one job, and another side we can able to fix another job. One is rotating and one is coming and applying the force. What happens? Therefore, one is rotating, it is ready to cause a rubbing action with the another one. And when you are coming here the rubbing action occurs. Obviously, welding also completed. The easiest machine in our laboratory workshops we can able to do this. Machine tools laboratory we can able to do this. Limitations. Restricted to joint around bars and tubes only. Not a flat plate is not possible. So that is one of the major limitations. That is, I am naming this as axial welding. What is this axial welding? Two objects to be kept like this. This axial path we have to keep. So this axial parts we are keeping. Likewise, only it is possible. Right? Therefore, alignment critical. Straightening fit-ups are needed. Post-weld machinings are needed. What is this post-weld machining? We have seen a formation of flash in this region. The formation of flash is there. In case, if needed, otherwise, if not required, we can use the job same as it is. If needed, we can able to remove machining to be done, these flashes to be removed. Where is the flash in the image? You see? So this one is flash. This one is flash. So this specimen is welded, shortened, and this one is flash. This one, if needed, we can remove. So therefore, machining is required at the later stages. Initial cost is high. Automated system, initial cost is high. So applications, there are many more applications in the automobile industries. Applications they are using in the aerospace, automotive, defense, marine, oil and industries, tubes, water pumps. See, steel up to 100 mm diameter we can do. I have shown on picture that is belong to 16 mm. But maximum up to 100 mm diameter we can able to do this friction welding process. In automobiles, in gears, engine valves, axial tubes, you see, you keep on noting this will be the round objects, or bars, or tubes, or pipes, such categories will be there. So driveline components, stud rods, shock absorbers, hydraulic piston, track rollers, gears, so these things are we can able to do welding. Have a look over these images which contains many more rod type categories of specimens which can be welded by the friction welding process. Maybe the pipe or maybe the rod bar types. So see, I have taken in this image of steel which is welded to the aluminium. Here the flash is formed. Here the flash is formed. Two specimens are combined together. So here and the friction welding is done at this location. The steel, mild steel has been used to the two components we have welded. So such components are possible to do the welding. See here, this location is welded by the friction welded components. So many more are there. You can able to do this. See, each and every round components or bar items are done by our friction welding processes. Only limitation, the plate cannot be welded. Other than that, the bar items are possible to do the welding methods. You see the various images we can able to look over, all are belong to round jobs or bars or rod items. So such have a look how many possibilities of friction welding are done. Each locations I have noted in the red colors you can able to see. So these are all processes are done by the friction welding methods. The summary: in welding we have seen about solid state joining process. In this solid state joining process we have seen about the friction welding, and this friction welding working, advantages and applications. The remaining part of the subject we'll see you in the next session. Thank you.